Okay, so finishing up, we have a y value of 0, a y value...
Math stuff out loud.
Yes, sir. A y value of -1, y value of -2. So -2 is going to be right here. Crap. No, it's going to be right here. And then -1 is going to be here and 0 is going to be here. So that's what our cosine -1 is going to look like, with this being y is equal to -1. Again, my peak is at 0 and my valleys are at -2. Again, did we have to do all this chart? No. We saw earlier that it was just that graph shifted down, but I think that practice helps. Now, what's the deal? Okay, so we did 5, 10, 15. Now we need 20. It just says find the amplitude of the period, then sketch. Okay, we're doing more. So if y is equal to negative sine of 2x, let's find the amplitude. Well, first I'm going to write it as -1 sine of 2x, because I think it's clear now that a is -1, b is 2, h is 0, and k is also 0. So the amplitude, absolute value of a, absolute value of -1 is 1. The period is 2 pi over whatever b is, so it's 2 pi over 2. But we know that that means that the step size is going to be period over 4 is pi over 4. From then, I'm ready to make my table. So I've got x's and negative sine of 2x's. Well, again, before I do anything, I see this negative is going to reflect it. So if this is my normal sine graph that I have, where I have 0, 1, 0, -1, 0, as soon as I put that negative, it's going to take all those positive values and make them negative, and 0 stays the same. So I know it's going to look something like this, right? But then here, notice what it did. It made the graph go twice as fast. So instead of ending my period at 2 pi, I'm going to end it at pi, right? So that's what I think my graph is going to look like. Here's 1, here's -1. Done. But let's go through that chart just to make sure that it's clear. So I have my starting value. If I think about my normal sine graph, over here, my parent function, I'm going to start at 0. And we're going to think about it as 0 plus 1 step, 2 step, 3 steps, and 4 steps. Where, how big is each step? Okay, let's see. We said each step was pi over 4. So that's 1 pi's over 4. That's 2 pi's over 4, 3 pi's over 4, and 4 pi's over 4. So now if sine are my old outputs, again, we said that my old outputs are what? 0, 1, 0, -1, and 0. My old outputs are 0, 1, 0, -1, and 0. We're going to take all those old outputs and hit it with a -1. And that's really algebraically going to do that reflection that we had. So it's 0, -1, 0, 1, and 0. And now we're ready to graph. So again, we said that our x values are starting point, pi over 4, 2 pi's over 4, 3 pi's over 4, and 4 pi's over 4. And we're going to start with an output of 0, go down to -1, go back to 0, go up to 1, and go down to 0. Just make sure when you hit a peak or a valley, you make it nice and round. So there you go. Again, just so what we said before, but now we understand it algebraically through the table. So that's 20. Let's now look at 25. So 25, if you look at 25, it is y is equal to 10, sine of a half x, sine of 1/2 x. Maybe that looks ugly. All right, it's 1/2 x. Now what do? Again, you let the reader know that a is 10, b is 1/2. It's pretty clear that h is 0 and k is 0. So the midline is at 0, and we're going to have some other business. So absolute value of a is absolute value of 10 is our amplitude. The period is 2 pi over b, so it's 2 pi over 1/2. That's the same as 2 pi times 2, which is 4 pi. So if I take all the inputs and multiply them by half, it slows down, and now it takes me a full 4 pi to make one complete cycle, where it used to only take me 2 pi, right? And then the step size is just your period cut into 4 pieces. So it's 4 pi over 4, cut into 4 pieces. Every step is pi. So if I was going to graph this thing, this k equals 0 tells me that the midline is y equals 0. So up and down, we are centered at 0, just like normal. And then the highest we ever get looking up is 10, and down is -10, because we go, way to think about it is, we go the amplitude of 10 this way to get to -10, go the amplitude of 10 to get -10 down here, right? So that's like an envelope that really holds the function. And so we know that our old buddy sine goes from a 0 to a peak to a 0 to a valley to a peak. So we think it's going to look something like this. But now what we have to do is 0. So it's 0 peak valley. 0 peak, 0 valley. It needs to be 0 peak, doesn't it? You can even see it from the way I'm drawing it. It is Friday, isn't it? Oh, and then back to 0. Back to 0 because it's Friday. All right. Now, so that's what we know sine is going to look like. It's stretched. But again, we now see that this 1/2 makes the period pi over 4. So this value right here that we end at, it's 4 pi. This value that we end at is 4 pi, because that's how long it takes to make one complete cycle. So that means every step is pi. So the first step is pi, the next one is 2 pi, next is 3 pi, and then last is 4 pi. So that'd be my graph, right? Now again, if we want to make the table to really help us out, we do x, and the function is 10 sine of 1/2 x. Again, we know that our starting point is going to be 0. So we're going to take 1 step, 2 steps, 3 steps, and 4 steps, where the size of each step is pi. So we end up getting pi, 2 pi, 3 pi, and 4 pi. This. This, yes. So, what am I thinking of? So now I need to do, sorry, I'm tired, I spaced out for a second. So now I need to do the y's over here, and notice what we've got. We have got our old sine values. So we're going to take all these. 0, there's 1, 2, 3, 4 steps. All my old sine values on the basic sine function, it goes 0, 1, 0, -1, 0. we're going to take all those old sine values and multiply by 10, yes? Right? So this is going to be 0, 10, 0, negative 10, and 0. And we see that reflected in the graph. Cool? Great work. Okay. So that one's that one. I need a y is equal to the cosine of x minus pi over 2. So in this case, it should be pretty clear. This one's number 33. It should be pretty clear from this that a is equal to 1, b is equal to 1, h is equal to pi over 2, and k is equal to 0. Because the way we could write this in in like some sort of a standard form, is 1 cosine of 1 times this stuff plus 0. So now it's clear where our A, B, H, and K are. So how does that help us? Well, amplitude is absolute 1. The period is 2 pi over B. So it's 2 pi over 1, which is 2 pi. What else do we have? Step size is period divided by 4. So it's 2 pi divided by 4 is pi over 2. So it's really the standard period, right? The only change we have is we have shifted this whole thing to the right, pi over 2. So now we're ready to rock it out. So again, what could we do? We could shift over pi over 2. I know that cosine is a peak, a midline, a valley, a midline, and a peak. So now overall it's going to look like this, right? Where we said k is telling you that the midline is y equals 0, and we go up, how much? 1, because that's the amplitude. We go down 1, because that's the amplitude, and it creates this envelope that the function must live inside, right? So we think that that's what the graph is going to look like. We just have to figure out what these steps look like. Yeah, let's do that right now. So if every step is pi over 2, well, I could just know one step gets me to 2 pi over 2, another one gets me to 3 pi over 2, another one gets me to 4 pi over 2, and the last one is 5 pi over 2. So that's definitely one way to graph it. All that shown, I think, would get you what you need. But just to be clear, I can go ahead and do the table if I need it. So the table is the cosine of, what is it, x minus pi over 2? X minus pi over 2. So this time, I have a starting point, which is finally different. It's pi over 2. So I'm going to take pi over 2 plus 1 step, pi over 2 plus 2 steps, pi over 2 plus 3 steps, and pi over 2 plus 4 steps. So what does that mean? That means if each step is pi over 2, then every time I'm going to have my starting point, which is now different, it's pi over 2, plus a step of size pi over 2. It just so happens this time that they're the same. So my start is pi over 2, then pi over 2 plus pi over 2 is 2 pi over 2. This is going to be 3 pi over 2. This is going to be, 4 pi over 2. And this is going to be 5 pi's over 2. But this is 2 pi, and this is pi, if you want to make it look nice. Right? But then when we come over here and we look at this, what are my old values of cosine that pop out? My old values of cosine that pop out are 1, 0, negative 1, 0, and 1. And there you go. That's why the graph is what it is. Let's take a second and look at 35. So 35 is y is equal to negative 2 sine of x minus pi over 6. So a few things going on here. if you want to write it in some sort of standard type form, it's really a 1 times an x minus pi over 6 and then plus a 0. So we're really seeing here that a is equal to -2, b is equal to 1, h is equal to pi over 6, and k is equal to 0. So we really just shifted to the right pi over 6 and messed with the amplitude, and that negative reflects it, right? So let's go through the chart. Yeah, so first, amplitude, absolute -2 is 2, period, turns out to be 2 pi. Then what? Step size. Yeah, none of that changes. All that is standard. Now we're ready to do our chart, which really tells the story. What's going on? -2 sine of x minus pi over 6. So now we start at a different place, pi over 6. And then from there, we take our starting point plus a step, plus 2 steps, plus 3 steps, plus 4 steps, right? So if this is my starting, my starting point, and then how much is each step? We said each step was pi over 2, right? But you know what I'm going to do? Before I put them in there, I could put pi over 2 every time, but I'm going to go ahead and make my life easier. Are you ready? I'm going to rewrite pi over 2 as, I'm going to hit it with, 3 over 3, and realize that that's 3 pi's over 6. So that's my step size. You see how those are the same? Why is that great? Because every time in here, I'm going to add in 3 pi's over 6, or some multiple thereof, right? So why is that beautiful? Because look what we've done. We've said, look, here you have pi over 6 plus 3 pi over 6 is a total of 4 pi's over 6. And then here we have 6 pi over 6, because 2 times 3 is 6 pi over 6, right? So 6 pi over 6 plus 1 pi over 6 is 7 pi over 6. So 3 times 3 is 9 pi over 6, right? So we've got 9 pi over 6 plus 1 pi over 6 is 10 pi's over 6. Here, I've got 4 times 3 is actually 12 pi over 6 plus 1 pi over 6 is 13 pi's over 6. Okay. Of course, we could write this as 2 pi over 3 if we wanted to, but I like that better. Of course, we could write this as 5 pi over 3. Again, I like this better because it really shows those steps in pi's over 6's. So what have we got over here? We've got our old values of sine that have each been multiplied by a -2. So our standard sine, our parent function, is 0, 1, 0, -1, 0. Those are the values of our standard parent function, right? Why is that great? Because now I'm just going to take all those and multiply by that -2, which is out front, which first reflects and then stretches by that amplitude. So I get 0, -2, 0, 2, and 0. So now we're ready to graph, right? So when I come over here and graph that thing, I'm going to start pi over 6 and take 1, 2, 3, 4 steps. The first step gets me to 4 pi over 6, and every time, again, we just take a step of 3 pi over 6, which is the same as pi over 2. So we get 7, and then 10, and then 13. I think that really makes the most sense, yes. All right. So notice, even though we could simplify this way and this way, in this sense, I don't think it's any simpler because it really makes the graph easier to read when you leave it all in terms of sixths. Okay? So again, we've got, now we're ready for our y values. We've got 0, -2, 0, 2, and 0. Cool. Goes on forever this way, this way. Where the height is 2, bottom here is, boop, bottom here is -2. Great work. Okay, so I'm going to hit stop and do some more.